Well, howdy folks, welcome back to the shop. So today we're going to be working on this rotor here. So this rotor is out of a 15 horsepower three-phase motor, and it started having some bearing issues. It was starting to make some noise and stuff. So they asked to see if I could work on it here. So to give you an idea, this is a 1 5/8 shaft here. This is actually metric size, and I believe it is. I have it written down here. So this is 45 millimeter. So it's like 1.7722. So it's, a little bit over 1 3/4 inch size. And so whenever I got this, I already polished up this end and cleaned this up a little bit. It was kind of dirty here, but I could see some marks in here, and they weren't terrible, but I'm assuming something happened, got in here, maybe a belt grabbed a stone. I don't know what the application completely is, but it got in here and chewed this a little bit, and you could see whenever someone pulled this bearing off, it made some score marks and stuff in this. So I went ahead and polished this end up, and then I mic'd it here real quick and made sure it was to size for the bearing. And also on this, where the pulley goes here, it looks like there was either a set screw or something here. It may be hard to see there, but you can see that there is a score line here too. And it was raised up a little bit, not much. So I took a file and knocked off the high edges, and then I went ahead and polished that up as well. I did mic this here, and it is exactly 1 5/8 on the nose. So there's no wear on this at all. So according to the bearing chart, this bearing it's on here is a 6309, and this shaft diameter for that bearing should be 1.7722 to 1.7718 inch, which is 45.0139 millimeters and 45.0037 millimeters. So I did measure it and verified it, and it's within tenths. I was really surprised that it was not wore as much as what I thought. It's on the high side. This might be the last time that we could actually do this without doing what we're going to do to the other end. But this is very, very close to size. So it's about 2/10 higher than what it calls for in the spec. 2/10 is not really enough for me to even worry about trying to, get a sleeve and stuff on this to repair this end. So this end we're not going to mess with. All we're going to do is we're going to chuck that up on this end and work on the back end here. So with that said, so this end here, I didn't even bother cleaning it up, and here's the bearing that's supposed to be on it, and it is a 6206 bearing. Well, if you put it on here, it is a little bit loose there. So I did measure it as well, and it's like 30-40 thousandths undersized, and you can see it's wore in there quite a bit. Even the bearing here looks like a wear mark into it, so it must have been sitting on here and just wearing away, So obviously we're going to replace the bearings as well. The front bearing that was with it, you can see it there. Surprisingly, I don't see anything wrong with this. I mean, it's up to whether they want to reuse it or not. I really don't care. I always recommend putting new bearings in anytime you do this kind of stuff, but that is completely up to them. So I looked up the bearing, the 6206 bearing, and this shaft size here is supposed to be 30 millimeter. So it's 30.010 millimeter or 30.0025 millimeter. There's your range. So the English measurement is 1.1815 to 1.1812 inch. So obviously it's wore out. So whenever I see this stuff all the time, one of the things you need to make sure of is make sure your bearing housings. So here's the end caps to this motor here. You need to make sure that these are to size. So I went ahead and mic'd these already. And whenever you look up the bearing spec, a lot of times it'll give you the shaft and the housing diameter. So the housing on this was supposed to be 62 millimeter. So it's 62.0166 to 61.9989 millimeter, or the English version is 2.4416 to 2.4409 inches there. And I measured it, and it measured 2.4408. So it was it was well within tolerance. It's right on the high side as well. And then the same thing with the front bearing. You know, I did mic this and well as well and checked it, and it is the same thing. It's within tolerance. It's on the high side of the tolerance on both of these, this front shaft. You can see on these guys, there is metal bushing pressed into this already. So I don't know if this was factory like this. I'm assuming it was. Some of them do have it like that way and some of them don't. Usually when you get into larger motors, they do have a metal sleeve in them. So, but what you normally do is you can just cut this sleeve out and then you can buy a sleeve and just press it in there. Or make your own, whatever, you know. But they are close enough to tolerance that I'm not going to worry about it. So all the work we're going to be doing is right here. So my plan is I'm going to clamp on this end here and then put my center in this, and then we'll go ahead and get this turned down. And that's one of the things I wanted to bring up too is, you know, this center and this side is in excellent shape. And this side here, it's hard to see, but, and I'm not faulting anybody for this, but it's very common you put your gear puller nose in there and then you end up destroying that center. But I mean, that's how you center up your gear puller to get these pulleys on and off. There is a center saver. I would recommend people use them because what would happen is if I couldn't get this center, like luckily this side, if I would chuck on this end, I could put my steady rest here and get me centered up and then recut this center on this end. But since I don't have to do anything on this end, all my work's going to be on this end. This center's in great shape because it's behind in the housing, so you can't get anything on it. But it happens. I mean, it's very common. I always try to use a center saver to get these pulleys on and off, and sometimes I don't. So I'm just as bad as well. So with that said, guys, I think what we're going to start doing is getting this cut up, chucked up in the lathe here and stuff. So what we're going to be using, this is a chunk of like 4140 stock. It's just a piece I had laying around here. And I kind of made a sketch here what we're going to do. So this sketch is basically saying that we're going to turn this shaft basically down to 1 inch, which isn't very much off of it, but it still should be enough. It'll be basically what it'll come out to is 2.5 millimeters on each side, and that's roughly 100 thousandths. So 100 thousandths material around this is going to be plenty. Luckily, it's the rear bearing, so most of the weight's going to be on the front of the bearing because that's where your belts and stuff are going to be pushing and pulling. So this one don't see as much load, but it still sees a lot of the load. So that's what we're going to do. So I measured from here to here, and this shoulder here is going to be 18 millimeter. And then the next shoulder, and it's a little hard to see, but there is a little bit of a step here. So I don't know if this was the original size here. It's possible. And someone already turned this down. You know, I can't tell if anybody's been in this one yet or not. It don't look like it, but I don't know. But regardless, we're going to change or turn it down to the size that we need. So like I said, this is 18 millimeters in, and then this is 20 millimeters to this shoulder, and there is a little bit of radius in this one up here. So I actually found a bit. It's called a thin bit, but it has the close enough radius in there that we're going to go ahead and use that tool. And then there is a little bit of a chamfer here, and I can see that there was a chamfer there. So, but that's what we're going to do is we're going to take and turn this down all the way up to this shoulder, and then we're going to make a bushing or a sleeve, and then we might end up heating it up and then pressing it on. Then we're going to press this on, then we're going to chuck it back in the lathe, and then we're going to turn this guy to size for the bearing. So with that said, guys, let's get over to the lathe and start cutting away. All right, so we're over here at the lathe, getting everything here set up. I got my soft jaws already installed over here, so I wouldn't mess anything up. And looks like I have to open my jaws up here a little bit more. What we're going to do is we're going to slide this guy all the way in. And it looks like there's about as far as I can get it. We're going to bring the tailstock up just lightly to hold it there for me. And then we're going to at least snug them up a little bit. And if you notice, this is getting pretty large for this lathe here, but I think we can still get her done. So first thing we're going to do is we're going to put the dial indicator down here, and get this guy indicated in. All right, we got her almost all the way in. According to the needle, I'm within 2,000ths. We're going to go ahead and get the center installed. It feels like it's good there. And then we're going to double check. I might be able to get it better, but I'm within 1 thou now. Yeah, right there's half a thou now. So once we got that side done in, what we're going to do is we're going to run this carriage back. And actually, we're not even going to do that. We're going to just use the indicator here, and we're going to double check on this end and see what kind of run out we got down here. Ooh, I'm not liking that. Looks like we got about 5,000ths. So what we're going to do is we're going to clean this center. I'm going to find a centering bit and just clean it a little bit. All right, so I was able to get this trued in down to about 1.5 thou. I mean, that seems the best I can do, so we're just going to go ahead and roll with it. That won't really hurt it, so we're pretty much ready to set up and start cutting. And what I'm going to do is I'm going to turn it all the way back to this line here, and then we're going to cut everything back in here. So we're going to go ahead and, like I said, start cutting all the way to there. All right, so I'm going to set my 0 there. So we're going to stop there, and we're going to mic it and see actually what we at. And we are, looks like we're 1.15, somewhere in that range. I'm not sure exactly where we're getting the vibration from though, but we still got quite a bit to come off here, so. All right, we're almost to size. We are, looks like we're about 3.5 thousandths oversized right now. So that's about where I want to shoot. So what my plan is I'm going to sand it in, probably get to 3 thousandths by sanding it. So we're going to run it up and clean off this surface here. And there we are. And all we're doing is breaking those corners real lightly. Now we're going to take and get that sanded. All right, that looks pretty good. So let's get one last measurement on here. What I'm measuring is, looks like we're 1 inch and 3/10. So I was shooting for 1 inch, so that's pretty good. So let's get this out of the lathe here, and let's get the piece we're gonna press on all fixed up, and let's start cutting it. All right, so we got our pieces of stock already chucked up here in the lathe, and I already went ahead and faced it, so we're gonna go ahead and get that center hole bored into this. So we're gonna get our pilot drilled. Alright, then we're probably going to use a 3/4 drill bit to go through there. So I found it looks like it's a 27/32 drill bit laying there. Alright, so we got a regular drill bit down through there. Like I said, it was a 27/32. Alright, so we need about 20 more thousandths to come out of this, and we're just going to sneak up on it because we want to make sure we hit the size. So there's 10. So we want to, like I said, we're sneaking up on it. All right, and we are right on the money at 10 thousandths basically to come out of this yet. So we're gonna go 8. We're sneaking up on it. So we know the shaft over there is ready to round exactly. It's a few tenths over 1 inch. So what we're shooting for is this one to be basically an interference fit. So we want about a 1/1000 interference fit. So I'm trying to get this one pretty much exactly on. And according to this, looks like we have about, if I can get 2 thousandths out of it, I would be okay. So that's what we're gonna do. Try for 2 thousandths. The finish in there looks really nice too. I'm very happy with the finish that's in there. Let's see where we're at here. Nope, I'm exactly right there. So you can see that I'm just a little under 1 thousandths. So I was shooting for the 1 thousandth. So we're gonna stop there. So what I'm gonna do is I'm gonna break this edge here. I'm probably just gonna use the Noga. Other than that, we're ready to get everything cleaned up and get this guy pressed onto the shaft. Alright, so I went ahead and made a new bushing here, and what we're going to try to do is we're going to try to heat shrink it on so it would not fit on this before I heated it here, and looks like we're about right at temperature, so let's see if we can get this guy on here. Alright, here we go. Look at that. Look, it won't even turn now. And that's exactly what I wanted it to do. So it is an interference fit. This is over 1 inch, and this is about 2 thousandths under 1 inch ID. So it should shrink to that, and you'll never get that thing off again. So now what we're gonna do is we're gonna let this thing cool overnight, because I want this thing to normalized. And then what we're gonna do tomorrow then is we're gonna go ahead and get this cut down to size. But so far it looks good. Alright guys, so we got everything set back up here in the lathe. So the first thing we're going to do before we do anything is get this end faced off flush. So it shouldn't take us that long to get that taken down, but I did leave that long one purposely. So let's get that cut down first. Alright, so you can see I just scratched that surface, so now we're going to get everything else cut in. Alright, so we're ready to get the first profile set into this, and if you remember my sketch, so the first thing we're going to cut in is this 35mm slot, and it's 20mm deep from the end, so it's 0.7874. So what I did is set my 0 down here, and we're going to go ahead and measure. Remember, there's that little bit of a radius that's in there, so we're going to go, I don't know, maybe just shy of 3/4, maybe 0.74, and then we're going to make a line, and we can cut this 35mm all the way down to that. And then we can cut our radius and then get that chamfer put in there. So down here's the 0. You can barely see it down in the bottom left here, but remember we just faced this, so we know this is the flush edge. So we're going to go over 740. So that's 1, 2, 3, 4, 5, 6, 7, and 740. So now we're going to come in here and we're going to turn it on and just make a little score mark. Alright, so that's where we're going to stop, and we're also going to use that as my 0. So now we're going to start cutting into 35mm. Okay, we're pretty much right there on the number. I'm at 378 and a few tenths, so we can polish the rest of that out. So let's go ahead and get our chamfer and stuff cut in. And that's all we need. You can barely even see that radius in there, but it is in there. Next we're gonna take and chamfer that. Okay, so this chamfering bit is a little bit sharper or steep of an angle than what's originally on here, but it will not hurt anything. So with that chamfer cut in, that little radius that's in there, we're going to go ahead and start cutting our bearing journal here. All right, so I'm going to go ahead and polish this a little bit in here because I might not be able to get to this shoulder very well after I get it done. So we're going to just use, it's 120 grit sandpaper. All right, so that looks pretty good. And that blended in real nice there too. You can almost barely see where it is pressed in there. Like I said, let's start working on this bearing journal here. If you remember, this is 18 millimeters deep, so that's 0.7087. So we're going to go ahead and mark that off. So there's 1, 2, 3, 4, 5, 6, and 7. And I said 0.87, 709, which is right there. So we're going to just come in here and make a score mark. And we're also going to take our dial indicator down here and set it back to 0. So that's my stop. All right, so now, if you remember right, this bearing fit is supposed to be 1.1815 to 1.1812. So let's start working it in. All right, let's get a measurement here and see what we're at. All right, guys, I apologize. We lost some footage there on the lathe towards the end. I was doing the final passes and polishing this in. I've been having problems with the GoPro batteries, and I've been hearing a lot of other people have been having problems with them. Just like this battery here, it was charged all night, and it still only shows 13%. And these batteries are only a couple months old, so I don't know what's going on. But anyway, regardless, so you can see everything turned out well. All the profiles into it. We'll take a quick measurement here to show you, and there we are. So the tolerance was 1.1812 to 1.1815, and we are at 1.181, and it looks like 4. So we're right on the higher side of the tolerance, but we're right there. So you know, this is the old bearing that was on there, but if you took a look at that, it still is very sloppy. So out of curiosity, I measured this bearing, and it is quite a bit over. So here was the measurement. Yeah, this is still set. I thought it would be, but we'll go ahead and do it again. But if you measure this, 1.8, almost 90, 1.90. So this guy is way out of tolerance. So this makes perfect sense. And we kind of knew that, you know, with it being sloppy in there, and you can see the wear marks inside here, you know, so that was kind of a given here. But so I don't have the new bearings with me. I was not provided them whenever I was doing this job, so this is all the farther I have to go with this. Like I said, all the bell housings and all that stuff, they're perfectly fine. A little high on the tolerance side, but they'll still be fine for this. I might recommend putting some bearing Loctite in there to, you know, help with some of that stuff. But if I do go over to his shop and we start assembling this, I will take some pictures and add them on towards the end here. But otherwise, so far, this job is done for me. So I hope you enjoyed watching it. Hope you learned something. And until next time, take care.